Hi. So in this session, we'll discuss formulas, but before jumping onto them, we'll discuss some of the basics first, like how to enter a formula. Let's take an example. Suppose I've got six numbers over here, and I want to calculate the sum of these numbers. Now, in order to call or use a function, the first step is to use an equal to operator. This is then followed by the function name. In this case, it's sum, then brackets open, and then I specify the location of these cells which I want to sum, brackets close and enter 73. There is another way by which I can pass on these cells separately. So let's say I've got a number over here and I want to pass all of them separately. I use sum, brackets open. Now because I'm passing all of them separately, I will separate them by a comma. And the last one, brackets close, enter. Now there is another way by which you can call or use a function, and that is through the insert function or fx option. When you click on fx, a prompt like this appears. By default, this option is most recently used, and because I just used some function, so that is why I can see the sum function on the top. But because some function is related to maths, I select maths and trigonometry, and then I'll scroll down all the way down to S. I've got some over here. When I click on it, it gives me a brief description also that it adds all the numbers in a range of cells. When I click on OK, a prompt like this appears, and now I will be passing values of all these cells one by one. So these are the cell locations, and I can also pass them by selecting them together. Let's select the last one also. And when I click on OK, it gives me number 82. One thing you may have noticed over here is that this number is showing 82 over here, but in the formula bar, I can see the actual formula that I selected I4, I5, I6. Then I selected I7 to I9 together, and then I selected I11 separately. Over here, if I scroll down to the second formula which we had used, I had selected all of these cells separately. And if I select the first formula which we had used, it shows that I had selected all of them together. So formula bar is pretty useful when you want to see which cells consist of formula or not. Because if I go to I4, it just consists of a value 1. So that is why it's not showing any formula. But over here, it is showing a formula. Now, at times when you're working with formulas, you want to edit a formula, you want to add or delete a parameter. So the best way is you go to the cell which you want to edit. Either you click on F2 or you click on the formula bar. So Excel will then show you which all cells are being considered, and then you can accordingly alter your formula. Now, because we had selected all these cells together, their border has been colored with one color blue. In this case, if I click on F2 or if I enter the edit mode, because we had selected these cells individually, Excel has given them individual colors, has given them separate colors basically. Now, because we had selected three cells together, they've got the same color over here. Just helps in visualizing and editing at times. Now let's move on to another interesting topic, which is called locking the cells. Now supposedly I've got this formula over here 73. Whenever I change the values over here, Excel will automatically update the formula values. So let's say I want to copy this value to somewhere else, supposedly over here, but I want the formula to be also intact so that when I make changes over here, the value also gets updated. But what we can see over here is that when we copied and pasted it somewhere else, the range automatically changed. So initially the range was in column I and our formula was in column J. Now that our formula is in column N, the range has shifted to column M. Now, in order to ensure that this particular formula or column N keeps on getting updated whenever this range changes, one way is that we drag the range back to column I, press enter. Or the other way and the most efficient way is to lock down these values or lock down these cells. So when I'm writing this formula, all I need to do is I need to press an F4. What this does is when a dollar sign appears next to my row number and column name, what it shows is that the cells have been locked. So now if I remove this and if I copy and paste this formula over here, now the value is intact. This is called locking of the cells. Now over here, what we did, we locked the entire cell together. Let's take another example. Suppose I've got some data over here and I want to calculate the sum of these columns. So I want to calculate the sum of this, I want to calculate the sum of this and sum of this. So what I'll do, I'll write sum and then I'll select this. Now the best way is that I just copy and paste them. So as you can see, entering into the edit mode, that Excel changes the ranges automatically. Now what if I want to paste this value over here now? As you can see, the range has changed, right? Over here, we want to lock the row numbers. So the formula should be based on row 4 and 5. So how do we do that? When you are writing the formula, go to the formula bar, enter into the edit mode, press 1 F4. So when dollar starts appearing in front of the row number and the dollar is not appearing in front of the column number, that means you have locked the row number. So now if I copy it over here, I get 3, and if I copy it over here, I get 5, if I get copy, and so on. Now what would have happened if, say, I had done an F4 over here and so that I had a dollar sign in front of I as well? When I would have pasted it over here, it would have worked fine. But when I would have pasted it over here, it would have not given me the correct values because now we have locked the cells rather than just locking the row numbers. So this is something which you will come across as you get more comfortable with Excel, as you use formulas on a daily basis, and whenever you want to copy and paste formulas from one place to another. Let's look at some of the options now. So let's go to File and click on Options, select Formulas. Now the first option which I'll walk you through is Calculation Options. Now what we had initially seen was that when we had changed the value of a particular cell, the value of the cell containing the formula automatically got updated. This is because by default this particular option automatic is checked in. But if I do a manual, then let's do an OK. So now what will happen is right now this particular cell is based on these two cells. Let's say I do a 5 over here. So the number is not updating automatically. So what you can do is you can go to formula toolbar, you in calculations, click on calculate sheet, and then it will update the number. Let's go back to the options again. So by default, this is automatic and that is the way it should be unless and until you really don't want Excel to calculate the formula values automatically whenever the numbers change. So let's leave it to automatic. Another option which I'll discuss over here is formula autocomplete. What happens is whenever you start entering a formula name after the equal to operator, Excel will give you options of the different formulas. So let's see how it works. So supposedly I want to calculate the average of all these numbers, right? So is equal to, as soon as I type A, Excel starts giving me all these different options. Let's continue to keep on typing. VE, I can see average over here using the down arrow button, and now clicking on tab, I select average. Now I can give the range of all these numbers, brackets close, enter. Now that we are in the formula bar, insert function is fx, what we just went through. Clicking on insert function again, these are the different types of functions which are here, or the different types of categories. It's same as what is mentioned over here in the function library. Now, trace precedence. It shows arrows that indicate which cells affect the value of the currently selected cell. So I've got a formula over here. If I select trace precedence, it just selects the entire range and tells us that if we are going to change anything in this range, this value will get updated. I can remove arrows using this. Similarly, I've got trace dependents over here. Let's see what trace dependent will do. Supposedly I click on 5. Trace dependent tells me that this particular value is being used across all these functions. So basically these functions are dependent on this particular value. Removing arrows to trace dependence. This particular cell J4 is being used in only two cells. One is over here and the other one over here. Let's remove arrows again. Show formulas. As you can see, it shows all the formulas which are there in the Excel file. Uncheck that. I will just come back to error checking in a while. Calculation options, as I said, it should be automatic, but if they're not automatic and they are manual, then you can use this particular button, calculate sheet, for updating the formulas in this particular worksheet itself. And you can use calculate now using just F9 or this, or pressing on this particular button to update all the formulas in the entire Excel file. Now, error checking and evaluate formula, they come in handy whenever we are facing issues, whenever we are getting some errors in our formulas. Let's take a simple example. Supposedly I'm dividing 1 by 0. So it gives me an error. When I use error checking, Excel tells me that the formula or function used is being divided by 0 or empty cells. So it gives me an idea what type of an error can there be. When you click on help on this error, an Excel guide opens which gives you a brief idea of what different types of errors are. When I click on next, it will take me to the second error in an Excel file. So right now there isn't any other error. So let's just close it. Let's use another problem. 1 plus 1 divided by 0. If I click on evaluate formula, right now it is showing me 1 plus 1, and as soon as I click on evaluate, it shows 2. So the first step has worked fine, but the next step would be 2 divided by 0. And as I click on evaluate, it shows me error. So basically implying that there is some error when we are dividing 2 by 0. Now with these basics done, for you to have a better understanding of formulas, practicing them and using them is the only way for you to get comfortable with them. So for this, I've created an Excel file which has around 50 plus functions. And for all these functions, I've given a detailed description of their syntaxes. I've given a description of what these formulas actually do. For each of these formulas, I've given some examples, notes wherever I found applicable. And then I've also given you some exercises to do. What I would strongly recommend you is to go through all of these formulas, do all the exercises, and come back to me with any questions or any queries you have. Or if there is any particular formula which is not being covered by this particular list, then do let me know and I will help you out with that. Thanks.
Hi, welcome back. Now the functions file which we have provided over here consists of somewhere around 50 plus functions, and we've tried to cover those functions which are used almost on a daily basis to manipulate data. Now what we have done, we've created some small videos wherein we look at some of these functions in detail so that you get more used to them and you can start using them in your work. Now the first function which we look at is if. Now, basically, if formula is used to check if a condition is true or not, and on the basis of that, it returns a value. Now, over here, we've provided the syntax for if function. So it is equal to, then we write the if function because we are calling it. Then we've got a parenthesis. Logical test is basically the condition which we want to check on the basis of which we want a particular value. So if the condition is true, then we will get value following the comma over here, and if the condition is false, then we'll get the second value. Now let's look at it how it works. So I've got an example over here. Now I've got four students, I've got their corresponding marks, and let's say I want to see if they've passed or failed over here. Now in the examples which we've provided over here in this particular Excel file, we have already used these formulas and then we've copied the syntax in the corresponding cells. But let's see how this works. So I'll remove this, and my passing marks are greater than equal to 40. So if the student scores more than 40, then he's passed, otherwise he's failed. So I'll use equal to. Now I'll call the if function. Now, as you can see that as you started writing, you got this automatic pop-up wherein Excel tells you all the different formulas which are starting with the if keyword. So because we want the if formula over here, now I've got if. I'll just click on my tab key and the parenthesis opens. Now the logical test over here is that the marks need to be greater than 40. So this particular cell consists of my marks greater than equal to 40. Now I'll put a comma because this is a syntax. Now because pass or fail is a text value, not a numeric value, so I'll have to use inverted commas, else fail. Now I'll close the parenthesis and I'll press enter. So now because this student had scored 90 marks, which is greater than 40, so that's why he has passed the exam. Now what you can do, you can either write the function for each of these cells manually, or you can also copy this function, select these cells and then just paste. So the formula automatically gets pasted and it will refer to these cells. So as you can see, it is referring to B23, B is this, and 23 is this. This one is referring to B24 and so on. Or you can do another thing. You go to the corner of this particular cell, and when you start seeing this black cross, just do a double click and the formula gets pasted automatically. So this is a function. I've got an exercise over here. So just go through it. And if you have any questions, then do let us know. Let's move on to logical AND. Now what AND function does is it basically returns a true or a false value. And it will return a true or a false value based on whether all the conditions which we have passed in the AND function, they are being met or not. So the syntax is equal to and then in the parentheses we are testing different conditions. Now in the if statement, if you remember, we were just checking one condition. In AND function we are checking multiple conditions, and if all of these conditions are met, then we'll get a true value. If even one of these conditions are not being met, then we'll get a false value. So let's look at this example over here. I've got the value in column 1 as 1, in 2 as 2, and I want to check if both of these values are greater than 0 or not. If they are greater than 0, then I will get a true value. If either of them is not greater than 0, then I will get a false value. Let's see how this works. So I will call equal to and function is greater than 0, or I can even write it B19 is greater than 0, parenthesis closed, enter. That's about it. Now I can paste the formula over here. So as you can see, because in the first row over here, both of these are greater than 0, so we are getting true. But over here, one of the values is not greater than 0, and that is why we are getting false. I've given an example over here where we are using and if function together. So go through it, and then we've got an exercise based on both using and if. And this will give you a very good idea of how these functions can be used together. Next, we'll move on to a very important functionality of if function, which is basically called nested ifs. So now if you recall, if statement just checks one condition, and on the basis of that, if the condition is true or false, it will return a value. In nested if, we can check multiple conditions, and on the basis of that, we can then have a value. The syntax over here is equal to if, then we are checking the logical condition over here. If the condition is true, then we'll get a particular value. But if the condition is false, now instead of specifying a value over here, we are again calling an if function, which will have its own logical test, and it will have again its own value if it's true or if it's false. Now, if we want to have more if functions involved over here, instead of passing a value over here, we can again call an if function. So this is again used quite a lot for data manipulation or when you are trying to create some variables. Now let's look at the example over here. Now what we've got over here is table A has the score threshold. So if a student scores more than 70, then they'll have grade A. If they score somewhere between 41 to 70, they'll get a grade B. And if it's less than 40, then they'll get a grade C. And I've got four students over here, 90, 70, 20, 41. So now I've got three grades, A, B, and C. If we just had two grades, then probably we would have just used if statement. But because we've got three grades, we'll have to use multiple ifs. So let's see how we are doing it over here. So my E26 over here is this particular cell, which is 90, which is the marks for the first student. So how this formula looks is we are calling if formula, then parenthesis open. I'm checking whether my score over here, 90, is less than 41. If it is less than 41, then we'll get C. But if it is not less than 41, then I'm calling another if function. Now what this if function again is doing is it is checking whether my score in cell E26 is less than 71. If it is less than 71, then it will give it a score B, else it will give it a score A. So this is how you can club multiple if statements together to check for multiple conditions. Now from Excel 2007 onwards, we can use 64 if conditions together. It does get a lot complicated as you keep on adding more if statements. But yeah, we can use 64 if conditions together, whereas Excel 2003, that just allowed us 7 conditions together. Now this is the last function which we'll cover in this video. In the next video, we'll discuss the text functions. Now OR function is again very similar to AND function. We are checking for multiple conditions over here, whether they are true or not, but it will return a true value even if one of the conditions is correct. So for AND, all of the conditions were supposed to be correct, and then only it would have given us a true value. But for OR, even if one of the conditions is being met, then it will return a true value. So for example, let's say I want to see if these values, if either of these values is greater than 0 or not. So let's see how this works. I'm calling my OR function, and I'm checking whether A20 is greater than 0 or B20 is greater than 0. True. And then I'll just copy them. Now, in the first instance, because both of these values are greater than 0, we are getting a true value. In the second instance, one of the values is greater than 0, whereas the second one is not. But because one of them is greater than 0, we are getting a value true. In the third instance, because both of the values are not greater than 0, we are getting a false. I've given an example over here where we are using OR and if function together. And then the exercise which is following this, again, that uses both OR and if. So do go through them. Thank you. Hi, welcome back. Now, in this particular video, we'll cover some of the text functions, and these functions are used to manipulate data, uh, concatenate data, extract information from, say, a particular value. So we'll go through these examples as we go through these functions. Now, the first one which we'll cover over is the exact function. Now, this particular function checks whether two values are exactly same or not. And when I say exactly, it also checks whether they are in the same case or not. So it is case sensitive. So let's look at the syntax first. Is equal to exact and then text1 comma text2. So these are text1 and text2 are the values which we want to check whether they are same or not. So I've got these two cells over here. I've got XL and XL written in both of them. So it's giving it a true value, and that is because both of them are same. But when I compare XL with XL, where the latter part is in small case, you can see it's giving it as a false value because they are not correct. So this is how exact function is used. Let's move on to concatenate. Now, concatenate, as the name suggests, it's used to join several text strings into one. You can have, when I say text strings, it can be numbers, it can be texts, it can be dates. So you can just club them together. There are a couple of ways by which you can concatenate two or more columns. So one is by calling the function concatenate and then parenthesis, string one, string two, and so on, whatever you want to concatenate together. Or instead of calling the concatenate function, you can use ampersand. So string one ampersand, string two ampersand, and so on. So let's say I've got these three columns over here, which consists of different data. So this is text, this is numeric, this is again text, and we just want to concatenate them together. So the first way is just use concatenate, pass the cell locations over here A20, comma B20, comma C20, and we'll get all of them clubbed together. The other way, as I said, is using ampersand. So A22 ampersand B22 ampersand C22. So that again gives the same result as using a concatenate function. Now you can also have spaces in between them. So for example, if I want my result or my output to have spaces between each of these strings, so I'll use the concatenate function. I'll pass on the first cell location, then followed by a comma. In my double inverted commas over here, I've got a space, then comma, then cell location again, comma, then again I'm passing a blank space, C24. So as you can see that all of these three strings, they have been concatenated together, but they've got a space between each of them. Similarly, just like you're passing on space, you can pass on semicolons or other special characters as well. So instead of a blank space over here, we've got a semicolon. So this is how concatenate function can be used. I've got an example over here, and so you've got three rows where you need to use the concatenate function and four where you need to use the ampersand function. So this gives you a good idea of how to use concatenate function. So let's say, for example, you've got name, you've got DOB, so Mark, Ted, Mark, date of birth is, let's say, January 18, then you've got Feb 18, then you've got March 18. Now, by the looks of it, if you just look at the name field, you will say that there are two distinct records. But both of these marks are different people. One was born in January 18 and the other one was born in March 18. So if someone says you to identify unique records just on the basis of name, what you might end up doing is remove duplicates, and you're basically just removing mark getting repeated twice. So you might think of, as just two records. But let's say if you concatenate them together, and this is just a very vague example of how it can be used. Of course, you can do the remove duplicates thing on both sets of the columns. So now it gives you that there are three different records. So this is just one way how you can use concatenate function. But again, as I said, it's very vague example. Now let's move on to the next function, which is trim function. Now, as the name suggests, trim is used to trim something. And in the case of Excel, it is used to remove leading or trailing spaces or remove extra spaces between words. So let's look at the syntax first. It's very simple. You just call the trim function and then pass on the cell location uh, for which you want to remove the spaces. The first cell over here, this does not conserve any trailing spaces or anything like that. So it will give you the output just like it is. If you look at the second value over here, it consists of extra spaces in between. So calling the trim function, it removes those extra spaces. In the third example over here, we've got some leading spaces over here, so it just removes them. And in the fourth one, we've got some trailing spaces, so it removes them. So trim can be used when, say, you are doing a VLOOKUP, which we will cover later in the coming videos. So trim function can be used then, say you've got data from two different sources and one of them has, and you want to match both of them. Say even if you're using an exact function and you want to match those. And now because this data is from different sources, one of them consists of extra spaces. So you can then just use a trim function first and then use an exact function or a VLOOKUP function depending upon what you want. So I've got an exercise over here also. So just go through it and yeah, you will get a better idea of how to use uh, trim and concatenate or ampersand together. Moving on to the substitute function. Now, as the definition states over here, it is used to replace a part of a text in a string with something else. Substitute function is also used to clean data, and this function is case sensitive. Let's look at the syntax. So first we are calling the substitute function. Then text is basically the cell location where you want to make changes. Old text is, say, the letter or the numbers which you want to change, and the new text is basically the values which you want now instead of the old ones. And the instance number is that particular instance of the old text which you want to replace with the new text. It is optional, but if you do not provide it, it will make changes to all the occurrences of old text with the new text. Now let's look at the examples below just to understand this better. I've got my string as hut and I want to make it as hub. So I want to remove this T. I want to replace it with B. So my function would be substitute. My cell location is A26. Then I'm substituting my old text, which is T, with B. So I'm getting as hub. Now let's look at the second one, which is Bumble, and I want to make it into Tumble. So I just want to remove the first B, not the second one, because then that will make it as Tumble, which I don't want. Now over here, then I'll have to specify the instance which I want to remove. So substitute, I want to remove B and that to the first instance of B, and I want it to be updated with a T. So this is my function. The next one is the car is in the driveway. Now let's say if I just want to remove the. So I'll just call substitute the, and over here I'm just replacing the by a blank space. The next one is the car is in the driveway. Now I want the result to be the car is in a driveway. So basically I want to remove the second instance or second occurrence of the in this particular phrase. So my substitute function would be substitute cell location the with an A, and I want to remove the second instance of the rather than the first one. The last one is the car is in the driveway. I want to remove the first the, so I'll just do a substitute A30 the. Now over here I have not specified any instance because as I said that this function is case sensitive, and over here this particular the has T as in capital, it's in uppercase, so that is why it is not doing any harm to the second occurrence of T. Again, I've got an exercise for you over here, so just go through it. The next one is text upper. As the name suggests, it converts the entire text string into uppercase. So I've got upper and then just passing on the cell location. So if I've got laptop over here, I want to change it to laptop with all capital letters. I'll just use upper and pass on the cell location. Similarly, if I've got Excel, I want to convert it into Excel with all caps, just use upper function. So that is all on the upper. Lower is opposite of upper. It will convert everything to lowercase. So I've got Excel over here using lower function. It will put everything to lowercase. Laptop with a capital L, we'll have everything lowercase. Length. Now length is used a lot with left and right functions, and it is used to extract data. So let's look at length first. So it gives the number of characters in a string, text or numeric value. It will also count the space and special characters. And as I said, it's used a lot for data manipulation or data extraction using the left and right functions. So I've got laptop over here. Now this has 6 characters. So if I call the function is equal to len and pass all the cell location, it will give me 6. Excel has 5 characters, but the reason I'm getting one extra is because I've got a trailing space over here. Superstore is closed, has 22 characters. 90, which is a numeric digit over here, has just 2 characters. Let's look at left. Now this function returns the number of specified characters from the start of the string. So let's say I've got a string as my left would be from this way. So it's from this to this, and my right function would be the opposite side. So it would be from this side, right? Anyways, so the syntax is equal to left text, which is the cell location and number of characters. So let's look at laptop, and let's say I want the first 5 characters. So I don't want the last P basically. So I'll have is equal to left my cell location comma 5. So it is giving me the first 5 characters. Next one is Excel is wow, and I just want Excel is. So that's first 8 characters. Excel has 5, then a space 6, and then is 2. So that is 8 characters. So is equal to left cell location comma 8 will give me this. Let's say I've got a number over here 90, and I just want 9, so it is equal to left, then I'm passing on the cell location comma 1. So this is how left function is used. There are 2 exercises over here. One just uses the normal left function and the other which uses left and length functions together, which is something I find really interesting for manipulating data. Let's say I've got data from a specific source which consists of the name, and then it consists of, say, the bank balance. And if I just want to extract the name, so I can use the left function. So as you can see, by using the left function, I can extract information from a specific phrase or a string. So as you start using length and left, right, mid functions more, you'll get more used to them. And these are very simple, straightforward applications of these functions. So then you can start making more complex functions out of them. Let's move on to the right function. Now, this particular function returns the number of specified characters from the end of the string. So as I said earlier, that left goes from A to H, whereas right goes from H to A. So it goes the other way. Now again, it's similar to left. It's used for data manipulation a lot, and the syntax is also very similar. Just that instead of left, we are using right over here. Let's say I've got my string as laptop and I just want top from it. So these are the first three characters from the end. So is equal to right A19 comma 3. Over here, let's look at 90 and I just want 0. So that's the first character from the end. So is equal to right A22 comma 1. Now over here, I'm using the length and the right function together. So what I'm basically doing over here is I'm using the right function. I'm passing on the cell location. I'm calculating the length of this particular value over here, and then I'm subtracting 16 from it. So again, I've given two exercises over here. One is just based on the right function itself, and the other one is based on right and length function together. So that is all what we'll have in this video. In the next one, we'll look at some of the date functions. Thank you. Hi, welcome back. Now, in this particular video, we'll cover some of the date and time functions. The first one is the date function. Now, let's suppose you've got your days, months, and years. They're all stored in different cells. Using the date function, you can pass on the cell locations of these different cells, and then Excel will return you a date. So the syntax is equal to date, then parenthesis, year, month, day, and let's say I've got this column which consists of years, this column which consists of month, and this column which consists of day. Now all I'm doing is equal to date. I'm passing on the year first, then I'm passing on the month, and then passing on the day. So that's about it on the date function. Date value. Now what this does is it converts a date which has been entered as text to date value, but in a number format. Excel basically stores dates in a number format. So the syntax is equal to date value and the date which had been passed on as text. So I've got these dates which have been passed on as text over here. So as you can see, there's an apostrophe over here, and that just makes it into a text. And what using the date value we are doing is we're just passing on the numeric value of this particular date. The next one is date today. As the name suggests, it returns today's date in a date format. If I write is equal to today, it will give me today's date, which is 27th of March. And say if I want to find out the date 5 days ago, so I will write is equal to today minus 5, which gives me the date 5 days before. So just like I've shown over here, you can use plus or minus with today to say give a date 30 days before or 30 days after, something like that. Now function. This function returns current date and time in Excel date and time format. So it's equal to now. So it tells me that right now the date is 27th of March and the time is 11:52. Similarly, I'm just doing a minus 5 and it tells me that it was 22nd of March 5 days before. Date, day, this function returns the day of the month, that is 1, 2, 3 till 31 in numeric format. So the syntax is equal to day serial number. So let's say using now function, I've got my today's date as 27th March, and if I use day function on that, it will give me 27. Similarly, this is the date 5 days ago, and if I use a day function, it will give me that day's date, which is 22nd. Month, as the name suggests, it returns the month. So over here, the date is 29th of March 2017, which is March, which is the third month. So that's why I'm getting the result as 3. Over here, it's 22nd of February, and because February is the second month, it's returning me a value of 2. Year, it will give you the year of the date which you are passing. Let's move on to minute now. Now this function returns the minutes between 0 and 59. So for this particular date and time, I've got 11:52. So the time is 52. Similarly, for 10:15 a.m., the time is 15. 10:20 p.m., the time is 20. Hour, this returns the hour from 0 to 23. So if it's 11:59 p.m., which is the 23rd hour, it will return 23. For 10:15 a.m., this is the 10th hour, so it will return 10, and so on. Now in the next video, we'll cover a couple of lookup functions, which are VLOOKUP and HLOOKUP. Thank you. Hi. In this particular video, we look at two lookup functions. One is VLOOKUP, which is vertical lookup, and the other is HLOOKUP, which is horizontal lookup. Now VLOOKUP is used to search a particular value in a table and then return data corresponding to that particular value from another column. Now the syntax for VLOOKUP is equal to, we call up the VLOOKUP function. Now this is the value which we are looking for. This is the table array or the other table where we want to find this particular value. We will want a specific column. So that is what we are going to specify over here. And range lookup, so this is optional. It has two values. True is for approximate, and false, which is default value, for exact match of the value we are searching for in a table. This will be clearer with an example. Now in this table, this is my lookup table, and I've got gearbox, engine, steering, ignition, CY head. I've got 3 car manufacturers over here. Now in this particular table, I've got the maker and I've got the corresponding spare parts. And what I want is, I want the cost. So for Mercedes ignition, I want the cost from this particular table. Now you can see that Mercedes ignition over here is 250, right? So using VLOOKUP, all I've done is I've used VLOOKUP. Now just let me scroll a bit up so that you can also see the syntax. Let me just hide this. Right. So now if you look at the VLOOKUP function, now B32 is ignition, and this is my lookup value. So basically I'm looking for ignition. The next I look at is A25 to B29. So I'm looking at this particular table. Now in this particular table, I'm looking at ignition. And why I'm looking at this table? Because I want ignition cost for Mercedes. If I had wanted ignition cost for BMW, my table array would have been this. Now, because I'm looking at ignition cost for Mercedes, in my table A to B, which is A25 to B29, my costs are in the second column. So that is why my column index is 2. So in the case if I wanted BMW ignition, the cost would have been in the third column. So in that case, my column index num would have been 3. But over here, because we are looking at Mercedes cost and the table is from A25 to B29, it just has 2 columns. And the last is false to get an exact match. Now let's look at another example. This is on BMW gearbox. Now BMW gearbox, my lookup value is gearbox, which is in my B33, and my table array would be this particular selection. Now over here, BMW values are in the third column. So that is why my column index num would be 3. And false again is for exact match. Let's look at one last example. Now this is for Audi engine 5200 pounds, right? Now Audi is in the fourth table. So this entire thing is going to be my table array over here. And my engine cost over here for Audi is 5200 pounds. So how I'm going about this is VLOOKUP B34, which is engine, and then I'm looking at my table array, which is this entire list of cells, and I'm passing on column index num as 4 because the fourth column in this particular table consists of the costs for Audi. And because I'm looking for Audi engine cost over here, that is why my column index num would be 4. And lastly, I'm passing as false because I want an exact match. Now this is another example. I've got table 1, which has cost of some of the items. Table 2, this is again the sales price of these items itself. Table 3 over here consists of these items, and it consists of the units sold. Now for identifying the cost, what I will do is, because I want the pen cost and the cost is in this particular table, I will do a VLOOKUP. I'm going to search for pen, which is A54 cell. And then this is going to be my table array, which is from A47 to B50. Now, because the costs are in the second column, it would be comma 2 and then false for exact match. Similarly, the same thing is going to be for pencil cost, notepad, ink. Now for eraser, this is hash NA, and this is because the cost table or the sales price table do not consist of eraser. So that is why we are getting a hash NA over here. Similarly, for sales price, I will refer to table 2. Again, if you look at the formula, I'm looking for pen in this particular table, which is my table array. It starts from D47 to E50. And basically, because my sales price are in the second column, my column num index is 2 and then false for exact match again. And then it's just doing some more data manipulation. So total profit is basically number of units sold into the difference between sales price and cost. So I've got some exercises over here for you. So if you go through them, you'll have a better understanding of VLOOKUP. Now let's move on to HLOOKUP. HLOOKUP is very similar to VLOOKUP, just that VLOOKUP over here looks at the vertical aspect, whereas the HLOOKUP would be looking at the horizontal aspect. Let's see how this works. So again, the syntax is going to be very similar. HLOOKUP, lookup value, table array, row index num. Now because in VLOOKUP we were looking at the vertical aspect, we were looking at the column index num. But because in HLOOKUP we are looking at the horizontal aspect, we would be considering row index num. Then again, range lookup, this has two values, true or false, false for exact matches. Now I've got one table over here which consists of some commission for car type. We've got car type as Mercedes, BMW, Audi, VW, Ferrari, and I've got the corresponding commission cost. Now this is the name of the employees who sold these cars, and for each and every car they sell, they'll get a commission. So now if I want to find out the commission which Ben earned for selling a Mercedes, I would use an HLOOKUP function. So I'm looking for Mercedes. This particular table is my table array. Now in this particular table, my commissions are in the second row. So that is why my row index would be 2 and then false is for an exact match. Let's look at Ken and BMW. Now value of BMW is in cell B35, which is my lookup value. Again, my table array is going to remain the same. It's going to start from B25 to F26, and the row which consists of the commission is in the second row of this particular table. So that is why comma 2 and then false for exact matches. Now, one thing which you may have noticed over here is this dollar sign. After the VBA module, we have a couple of videos which explain this dollar sign. This dollar sign is basically related to locking of a cell. And once you go through that video, it would be very clear for you. But as of now, whenever you are doing a VLOOKUP function, make sure that you've got these dollar signs. You'll get them by going to the range and pressing F4. So if I press F4 now, the dollar sign, one of the dollar signs removes. Now corresponding to the row number removed. Now the dollar sign altogether, the column and the row number have removed, and now I've got the dollar signs for both of them. So basically this is called locking of cells, and once you look at that video, you will be very clear about what I'm referring to. Now in the next video, we look at some of the math functions. Thank you. Hi, in this particular video, we look at some of the math functions. The first one is sum, and as the name suggests, it is used to return the sum of cells or the range selected. And the syntax is pretty simple. So is equal to, you call the sum function, and then in the parentheses, you pass on the cell locations which you want to add. Now over here, I've got three columns which I want to add. So my sum function looks like is equal to sum, and then I just select the entire range. Let's see. So I'm deleting this is equal to sum, and now I'm just selecting all the three cells together. So this gives me 34. Now, if I want to add this, now I can very well do it in the similar fashion, but over here I've selected these cells one by one. So this way we can select cells which are not written together. So for example, if there was a value over here also, and I wanted to add this particular value also to this, so all I would do is comma, just press enter. And there is another way by which you can sum cells, and that is using the plus operator. So all you need to do is, let me just delete this, is equal to this plus this plus this. Let's move on to the next one. SUMIF I'm not going to cover over here. I've got another video after the VBA module which covers SUMIF, SUMIFs, but do go through this exercise. Sum product. Now this function returns the sum after multiplying numbers in an array. It can also be used to count cells based on criteria provided. So let's look at the syntax is equal to sum product array1, comma array2, comma array3 and so on. Array1 is the range of cells which first need to be multiplied and then summed. In array2, it is optional, the second array or range to multiply and then summed. So let's look at this example. I've got items over here, whether they are perishable or not. I've got cost and number of units. Now over here, I want to calculate the total cost faced by the superstore. So first what I'll need to do is I'll need to identify the total cost for each of these items and then sum them all together. Now there is one way by which I can calculate the total cost. That is by first finding the total cost for each item and then adding them together. Which is $7,993.5, or using sum product, what I've done is I've passed on the array first C18 to C23, which consists of all my costs, and then I've passed on the second array D18 to D23, which consists of the number of units. So what Excel then does is it multiplies each of the corresponding cells and it gives us 7994, which is equivalent to what we've got over here. So using sum product, we were able to get the total cost within just one statement rather than calculating individual total costs and then summing them together. Now the rand function returns random numbers greater than 0 and less than 1, and the numbers can change on recalculation. The syntax is pretty straightforward, is equal to rand and parentheses. There are no parameters which need to be passed. And over here, I've already used the rand function, but if I press F2 and then enter, as you can see, all the numbers changed. Let's do it again. Now, rand function can be used while we are doing statistical analysis in Excel. rand between. Now this particular function returns random numbers between specified numbers. Now with the rand function, we were able to generate random numbers between 0 and 1, but with rand between, we can have random numbers greater than 1 as well. Now the syntax is straightforward, is equal to rand between. Then in the parenthesis, we are passing on the lowest value and the highest value between which we want the numbers to be. So over here, I've calculated my rand between 0 and 100,000. If I click on F2 and then if I click on enter, all of these numbers change. Now the next function we look at is math round. Now this function rounds the numbers to a specified number of digits, and the syntax is equal to round the cell location and the number of digits to which we want it to be rounded to. Now over here, if I want to round 45.3976106 to 45.40, that is basically to two significant digits, I'm using is equal to round cell location comma 2. Similarly, if you look at 85.4139 and I want to round it off to three significant digits, it gives me 85.414, 33.589, and if I want to round it off to 34, it is giving me round A21, 0. Even this function rounds a positive number up and negative number down to the nearest even integer. So 45.3976, the nearest even round digit would be 46. For minus 50, it would be minus 52. For 85, it would be 86. And for 33.58, it would be 34. Let's see if this was 32. Then also it is 34. And if this was 31, then it is 32. Math odd, similar to even, it rounds up the positive number and negative number down to the nearest odd integer. Mod function, this function returns the remainder after a number is divided by a divisor. The syntax is equal to mod number and the divisor. So let's say I've got a number 3 and divisor as 5. The remainder would be 3 as 3 cannot be divided by 5. 19 divided by 3, remainder would be 1. 8 divided by 2, remainder would be 0. And minus 8.5 divided by 3, remainder would be 0.5. In the next video, we will look at some of the statistical functions. Thank you. Hi, welcome back. Now in this video, we will look at some of the statistical functions. Now the first one is min. This function returns the smallest number in a given set of values and it ignores logical values and text. The syntax is straightforward, is equal to min, then in parentheses the numbers which we want to check for or the numbers from which we want to identify the minimum value. Now over here I've got three values 3, 5, 3, and if I want to identify the minimum number, I will just call up the function minimum and then pass on this range and it gives me the result as 3. Now 19a1, this gives me 1. It has ignored a text value. 8bc, it gives me the minimum value as 8. Minus 8.53 and zero point 0.5, it gives me the minimum value as minus 8.5. Moving on to the next one, which is max. It's opposite of minimum. It gives the largest value in a given set of values and ignores logical values and text. I will not be going through this particular formula over here. Average. This function returns the average value of the given numbers. It ignores text values and blank cells. The syntax is pretty straightforward, is equal to average and then in the parenthesis the range of cells for which you want to calculate the average value. Now over here I've got number 1, number 2, number 3, and the first row has 3 blank and 5. This is giving me as 4 because it is ignoring the blank cell. 19a1, again it will just consider these two. 8bc, it will ignore these two and it's just giving 8 divided by 1, which is 8. And over here it is going to first sum all of them and then divide by 3, which is minus 1.6667. Moving on to the next one, which is small. This function returns the nth smallest number from the given set of values. Now the minimum function gives us the lowest value, but what if I don't want the lowest value? I want the second lowest value or the third lowest value. In that case, small or large functions can be used. Now small, my array or the range of cells, and the nth small number from the list. Now this is my array or list of numbers. Let's say I want the smallest number. So the smallest number over here is minus 8.5. So as you can see, I've just done small. I've passed on the entire array from A18 to C21, and then D18 basically consists of the value 1, basically the smallest number which I'm trying to identify. So it is minus 8.5. Let's say I want to identify the fourth lowest value. So for that, it gives me the result as 1. So again, I'm passing on the entire array, and then I'm passing on the value 4 as the fourth smallest number from the entire table. I've given you one exercise over here, so just go through it. It will help in better understanding this function. Large is exactly opposite of small, so I'm not going over here. Count. Now this function returns the count of number of cells which consist of numbers. The syntax is equal to count, and then we are passing on the different cell locations. So for example, in this particular row, I want to count the number of numbers. I'm just using is equal to count, and then I'm passing on this range. It gives me a result of 3. Over here, it gives me a result of 2 as A is not a numeric digit. Then 8 blank 20, again it gives me 2 because this is blank. Minus 8.5 blank B, it gives me 1 because this is the numeric digit over here. Countif. Now sum if, sum ifs, average, average if, average ifs, count if, count ifs, they're almost identical. And once you go through the sum if and sum ifs video after the VBA module, you'll be in a better position to understand countif, but I'll quickly give a brief description of this function over here. Now this function returns the count of number of cells which conserve numbers and meet a specific condition. So I've got my countif, range, and my criteria, and this is that criteria which if it is met, then only we want the function to count that particular cell. Now over here I've got 4 columns which consist of numbers. The fifth column, column E, it consists of the criteria which I want to check. So for the first example in row 18, I want to check, or basically I want to count all the numbers which are greater than 1. So by just eyeballing them, I can identify that there are 3 numbers which are greater than 1 and the fourth one is equal to 1. So if I look at the function, it is equal to countif. I'm passing on this entire range A18 to D18, and then I'm passing on my criteria, which is that it should be greater than 1. The second one looks at value equal to 0. If you just do an eyeball, there is only one value which is equal to 0. It is ignoring the blank cell. And as you can see with the formula, we are passing on the entire range A19 to D19, where value is 0, it gives us 1. Let's move on to standard deviation. Now this particular function gives us a standard deviation of a given set of values. In terms of statistics, the lower the standard deviation, the better, as it implies that there is not much variance in the data and the population is more identical. Blank cells, text and error values are ignored. So standard deviation, and over here in the parentheses we are passing on the numbers. Now this is my range of numbers over here. If I want to calculate the standard deviation of them, I'm just doing is equal to stdev.s, because this is just a sample, and then A16 to D16 is the range of cells. So it's giving me a value of 13.07. If I look at 42, 40, 47, 47, the standard deviation is just 3.559. And if you compare all of these standard deviations, this is the lowest. And as you can see, if you compare these four numbers also, they are more or less near to each other. So that is why standard deviation is less. Variance is the square of standard deviation. So again, as with standard deviation, the lower the variance, the better. But it also depends upon what sort of analysis you are doing. Because if you're doing clustering, you would want the variance within a cluster to be less and variance between two clusters to be more. The syntax is equal to var.s and then you're just passing on the numbers over here. And if you look at the last row over here, this has the least variance as compared to the upper numbers. Basically, the numbers are exactly the same as what we had for standard deviation. It's just squaring them. Let's look at the next function, which is correlation. Now, this particular function returns the correlation coefficient between two data sets or two arrays. Now, correlation usually lies between -1 and 1. If the correlation is negative, then it is termed as negative correlation. Otherwise, it is termed as positive correlation. If it is 0, then it is termed as that there is no correlation. Let's take an example of a positive correlation. Now, as a baby grows older, the baby's height or weight increases. So this tells us that there's a positive correlation because they both are increasing together. And if I look at a negative correlation example, let's say you've got your salary account. Now, as your expenses increase, the balance in your account reduces, which tells us basically when one is increasing, the other is reducing. So that is negative correlation. Let's look at the syntax is equal to correl and array1 and array2. Basically, we're passing on the arrays between which we want to calculate the correlation. So this is my age and this is my weight. So as you can see, with the increase in age, the weight is also increasing. And if I use the correlation function on this particular array, it is giving me a correlation of 0.993, which is positive correlation. Let's look at median. This function returns number which is in the middle of all numbers in a data set. So is equal to median and then the list of numbers. So I've got this list of 20 odd numbers over here and I want to calculate the median, and the syntax is pretty simple, is equal to median and then I'm just passing on the cell locations, so it gives me 84. Now let's see if we can calculate it manually. Just copy them over here, put a filter and then sort them. Now, as the definition states, it returns the number which is in the middle of all numbers in a data set. So I've got 21 observations over here. So the middle observation would be 11. The 11th observation should be my median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which is 84. Now, lastly, we'll cover normal curve over here. And basically, we can calculate it using average and standard deviation functions. And now I've got this list of data over here, which is somewhere around uh, 4,700 observations, and these are all random numbers. Now, the first thing for me to calculate a normal curve would be to calculate z, which is x minus mu by sigma. So x is my observation, mu is the mean of all of these observations, and sigma is the standard deviation of all of these observations. So I've calculated the z value for all of them. For calculating mu, which is mean, and sigma, I've used the average function and I've used the standard deviation function, which we have just gone through. Now, once we have calculated z, we have calculated rounded z, which is using the round function. So we have used a round function for all of these values and we've rounded them off to 0. And then using a pivot table, the maximum value for round z is 4 and the minimum is -4. These are the number of data points across all of these. So this is how our normal curve looks like. So that is all we have on the function side. Now, if you have any queries around a specific function which you use in your day-to-day work or which you want to know more about, then just drop us a note. Thank you.